So now we're going to look at some parametric equations. And so parametric equations are a really useful tool. And if you continue in calculus, you're going to be doing a lot of this kind of stuff if you do multivariable and everything like that. So the way you want to think of it is x and y aren't directly related. They're related by an independent parameter t. Okay? And so you want to think of x and y, like different t values will give you a value for x and a value for y. So let's say, let's make a table here. When t is -3, the x value is given by -3 squared, which is 9. 9 plus -3 is 6. The y is given by 1 minus -3 squared, which that's 1 minus 9. That's -8. Then -2, do the same thing. That's going to be 4 minus 2, that's 2. 1 minus -2 squared is 4, so 1 minus 4 is -3. When t is -1, x will be -1 squared, which is 1, minus 1 is 0. And when t is -1, it'll be 1 minus 1, because -1 squared is, so that's going to be 0. And then when it's 0, x will be 0, y would be 1. 1 would be 1 plus 1, that's 2. 1 minus 1 is 0. At 2, it would be 4 plus 2. That's 6. And then 1 minus 4, -3. And then when t is, say, 3, it would be 9. 9 plus 3 is 12. And then 1 minus 9 is -8. And so then to plot it, you just look at all the xy pairs that I have, right? I'm just going to plot the ones near here because the ones that are further away are kind of hard to. So I have a 0, 0. I have a 0, 1 here. I have a 2, 0, like this. I have a 2, -3, so like down here. I have a 6, -3. So it looks like kind of, so 6, -8, it's like way down over here, for example. So it's going to go like this if I go in order from t going from -3 to -2. It's going to go like, oops. Actually, which way did it go? It went through this point, then it goes through 0, 0, then it will come here, then it will go here, then it will go to 6, -3. So, like over here. And then 12, -8. I don't know. It looks something like that. And that would be the direction of the shape. Something to that effect. Looks like that. Okay, so that's kind of how you want to think about it. Now, how do I indicate the arrow is usually I draw the arrow in increasing t. So I go through the points that are increasing t. So there's a direction associated with parametric equations. Okay, so let's look at number 2. Same thing, I have -pi/2 to pi/2. So I'm going to make a table of x, y, and t. And let's go from increasing t. Let's start at -pi/2. Let me see, -pi/2 is down here. So I could do, I don't know, -pi/4, then 0, then say pi/4, and then pi/2. Like that might be an easy way. So x is always going to be 1. Look at this. X is always the same value. And y is going to be based on the cosine. So 3 times the cosine, that's 0. 3 cosine of -pi/4. Cosine -pi/4 is √2/2. So that's 3 √2/2. Cosine of 0 is 1. So this is going to be 3. And then this is going to be also 3 √2/2. And then 0. So my graph is going to start at 1, 0. We'll pick that about there. We'll make that 1, 0 here. Then √3, like 1.5 times √2, that's like 2. That's about like 2 or so. So it's going to be 1, 2, like around there. Then 1, 3. Then back down to all the way down there. So it's going to go like this, and then come right back down the same way. This is going to be this. It's going to go up and then down. So it's just going to be a vertical line because the x value is constant, so the y is the only one changing. Okay. All right. So x, y, t again. T, we're going to go -2, -1, 0, 1, and 2 because that's the range of t that they're given. X is given by t squared. So t squared is just going to be 4, 1, 0, 1, 4. Y is given by 2, so 2, 2, 2, 2, 2. And so this is just going to be the y value is going to be a horizontal line. Y value is 1, 2 here, and it's going to go 4 to 4, 2 to 1, 2 to 0, 2 to 1, 2. So it's going to be this line segment between the endpoints 4, 2 and 0, 2. Okay. Thanks for watching. If you enjoyed this video, I go through a lot more of these exact kinds of problems with much longer videos on my website. It's entirely free. Check out the link in the description below.